This is not what I ordered. This is not what I ordered.
There are lots of types of LEDs out there. Big ones, little ones, coloured ones, white ones, even infrared. What we have here is a selection of common ones in the standard sizes, which are 5mm for the big ones and 3mm for the little one. The great thing about these sizes is that they're pretty much perfect for Lego. The little 3mm one slots right into a standard 1x1 headlight brick, and most 5mm ones fit easily into Technic brick holes like this, which we can use for things like train signals. Now you may find that some LEDs don't quite fit, like this white one, but since it's just a plastic coating, you can file down the sides with a metal file to make it fit. Voila! So how do they work? Look closely, and each LED has two legs, one longer than the other. We just need to connect these to a power source to make the LED light up. The long leg is positive, the short one is negative. For each LED or group of LEDs, you need to fit a resistor. If you don't fit a resistor, you can kill the Arduino, so be careful. This one's 470 ohms. So we fit the LED to our breadboard between the resistor and the ground, and then we connect the resistor and the ground to the Arduino. Now this is an infrared sensor, and we used one of these in our infrared tutorial. If you pair this up with an infrared LED, you can make distance sensors for detecting things like trains. You can even buy them as a pair. This little package is called a TCRT5000. The idea is that the infrared light shines out of the blue LED, bounces off whatever you're detecting, and reflects back into the sensor, giving you a signal. If you use the bigger LEDs, you can make more powerful sensors, and with a few resistors and a cheap circuit board, you can fit the whole package into a 1x2 2-hole Technic brick. Here's one I made earlier. Instead of reflecting infrared, you can also use a direct method to build an infrared gate. This shines the infrared light directly into the sensor, and you get a different signal when something breaks the beam, just like the red lasers in a bank vault. If you just want to make some pretty lights, here's the simplest way. This is a string of LEDs. I've got 4 little white LEDs wired together, and this is called parallel wiring. All the positive legs of the LEDs are connected to one wire, and all the negative legs are connected to the other wire. Down here at the end, the positive wire has one resistor to protect the Arduino. Use an online calculator to work out how big this resistor should be. It needs to be big enough to protect the Arduino, but not so big that your LEDs don't light up. I'm using this string to give my big yellow station some evening lights. Now that we know that LEDs can be used for lights and for sensors, here's the plan. We've got a simple loop of track with a switched section for a station and 2 locomotives running in opposite directions. If the black train's at the station, the green train can go round one way. If the green train stops, the black train comes out of the station and goes round the other way. Let's look at the code that's going to make all that happen. Here's our sketch. We're going to do 3 things at once with this program. Control the trains on the track using IR sensors, run a signal light for one of the locomotives, and control some lights for the station. Since there's all this going on, we're going to use lots of our Arduino's pins. We've got 6 pins for our motor controllers, 2 for our infrared sensors, 1 for a regular light sensor, 2 for our signal lights, and 1 for our station LEDs. Since all of these require power as well, we'll need a breadboard to physically set all this up. The next bit of code tells you that we're going to run a state machine. If you've not heard of these before, check out the junctions tutorial where we build our first state machine in the code. To make it all work, we need variables for the sensors, a timer, a counter, and the states, plus some fixed values for the interval and the light sensitivity of each sensor. To make this simple, all the sensors will use the same sensitivity value. In the setup, we declare all the output pins. Since we're turning on a lot of LEDs in the program, we need to declare the relevant digital pins as outputs. If you don't, your LEDs will glow very dim, if they work at all. We're also setting the train motor controller pins to low for safety, and the track switch motor speed to the maximum. The program has 6 states, because I think there are 6 things to check and do. We'll start with the red train at the station. When a timer has counted 3 seconds, it turns the signal LEDs from red to green, and immediately sets the train running in one direction. It saves the time, and then switches to the next task. Here we start checking the infrared sensor for the red train. We do this after 3 seconds, so that the sensor doesn't detect the train immediately. That gives the train enough time to leave the station. When the train returns to the station and triggers the sensor again, we add 1 to the counter and switch the signal light from green to red. Before we do anything else, the Arduino then checks the ambient light sensor that controls the station LEDs, and if the sensor is dark, we turn the lights on. We don't want to check that sensor every millisecond because it slows everything down, so we've just cut it into its own little state to make a quick check before we switch the track points, and that code is down here at the end. Every time we switch the points, we save the time and stop whichever train was running before checking the counter. If the counter is an even number, we switch the points straight and tell the green train to go. If the counter's odd, we'll switch to the station and power up the red train. Taking a quick look back up, the green train cases are identical to the red trains. We wait until the timer has 3 seconds since we switched the tracks, and then we power up the train in the opposite direction this time, and start checking the other infrared sensor. As soon as the green train's detected, we check the light levels and switch the tracks again. And that's all it takes. Here's what all that looks like in action. We've got the Arduino next to the big messy breadboard of wires to distribute power and ground wires to all our sensors. Here are the 2 infrared sensors to detect the train, and here's the signal lights for the station. The motor controller is controlling the track on one channel, and both point motors on the other channel. And our ambient light sensor is controlling the station lights. When we power it up, it needs 5 seconds, and the station train pulls away. It'll do a full loop, and when it comes back to the station, it stops, then the points switch, and after 3 seconds, the other train goes round in the opposite direction. Our signal lights indicate the status of the station-bound train, and when things get dark, the station lights up automatically. So that's everything you need to get started with LEDs for your Arduino powered Lego train. Thanks for watching.